Next we will talk about vertical hyperbola. Let me see, everything's good here. Okay, it's still running. Good, perfect. All right, so the second part, okay, is about vertical hyperbola. Okay, I will tell you what is the difference between horizontal and vertical hyperbola. You look at the equation, you know right away. The vertical hyperbola, it look like this. So we have x and y axis. Okay, and instead of having x-axis as the major axis, we will have, for vertical hyperbola, we will have y-axis as the major axis. Okay, it means that our hyperbola will look like something like this. So I'm gonna have something here. Okay, something like that. Okay, so it means that we will have B1 over here, and we have B2 here as the vertex, right? And we have the center box. So what if the center box is like this? Okay, the center box like that. So it means our A1 is here and our A2 is here. So the vertex will be B1 and B2, and that's what the coordinate of this vertex will be 0, B, and over here could be 0, negative B. Okay, for A1 the coordinate will be negative A0 and A0. Okay, and I'm gonna draw the equation asymptote. So the asymptote will be something like this. Okay, something like that. Okay, all right, so our focus will be over here, so it will be F2, and over here, and over here we have F1. So the coordinates, let me use the different color, will be 0, C, and over here will be 0, negative C. Okay, and the equation for vertical hyperbola will be a little bit different. So it will be, so instead of have x square in the front, so we have y square over b square minus x square over a square in the front. Okay. Oh yeah, there's some textbook they're gonna put y square over a square and x square over b square. It doesn't matter. It's just the name. You can put a b, or even you put mn or whatever you want. Okay, it's just the name. Okay, so the major axis will be OY. Okay, and the relation between ABC is still the same because it's addition. So we still c square will equal a square plus b square. So I'm gonna box this and I'm boxing this. Okay, so you see the difference? It's just they switch the position between x, y, b, a. Okay, and we have eccentricity will be c over b. Will be c over b. Okay, because at this moment for this vertical hyperbola, the major axis is the y, so it will be c over b. The directrix will be x equal to, will be it will be y, I'm sorry, it will be y, it's not x anymore, y equal to plus minus, so instead of a squared over c, right, but right now because this is the main one, so it will be b squared over c. Okay, and the asymptote will be y equal to plus by minus, so it will be what do you think? So in this case it's still plus minus b over a x. Okay, yes, it will be b over a, still the same. So the asymptote is the same. It's nothing changed for the asymptote. Okay, nothing changed for the asymptote. Whatever the values or the well, I mean, it makes sense though, because this is slope over here, rise over run. The rise is always the b, rise over the b, a is the x, so rise over run, so it makes sense. It makes sense. So it's always the same over there for the vertical hyperbola. Okay. Now, all right. Now let's talk about when we have a vertical hyperbola which the center is not the origin. What if we have somewhere else? Okay, what if I have something like this? What if the center is right over here? Okay, what if the center is over here? Okay, so I mean the major axis is this. All right. And what if I have something like this? Okay, something like that. And over here I have something like this. Okay. Okay. So this is oh, I'm sorry. So this is wrong. Yeah, I draw the wrong one. Let me get the eraser, because this is the center already. So I need to move up. Okay. So this is the center. So this is I. So it must be like this. Okay. All right. So this is my B1 over here. This B2. I'm sorry. This is B1. Okay. Because the center is moved, so the coordinate it won't be the same as this anymore. So this is the I over here. So the I over here will be H and K. Okay. And I have the center box like this. So the center box like that, it means our A1 is here, our A2 is here. Okay. And I have the asymptote like this. Okay, asymptote like that, and here. The asymptote is always go through the corner, the vertex of the box. Okay, so the asymptote like that. C is the distance, so F1 right here. So the F2 right here. I'm sorry, F2 here, F1 here. So F1 is we don't know the coordinate because everything changed already. So C is from here to here. So this is the C. This is the I mean, because the coordinate changed, so but I'm gonna say that the C over here will be changed correspondingly to C is the distance, so C is distant, but the coordinate will be changed correspondingly to the coordinate of the I. Okay, but C is still the distance. Okay, A is B is from here to here, so this is B. Okay, and A is from here to here. So the equation we have will be y minus k, because we do y first, square over b square, minus x minus h square over a square equal 1. Okay. Eccentricity could be the same, you know, it's still between 0 and 1. Okay, c square equal to a square plus b square, so those things the same too. The second thing that change is the asymptote. Okay, the asymptote change. Okay, the Directrix equation will be the same. The asymptote will be y minus k equal to plus minus b over a x minus h. Okay. All right. Yeah, the ABC is just the distance. All right. But when you want to write the coordinate, you have to draw the picture. Okay, and you can get the coordinate. All right. All right. Let's jump to the example. First example. All right. Let's see. Let's see what we have here. Okay. What if I have something like this? Let's see. Okay. Excuse me. So I have equation 16x squared minus 9y squared equal 144. Let's check one more time, so everything is still recording. Yep, still recording. Okay. Okay. So what we have over here is, I'm sorry, this is plus 144, so equals 0. So we will have 16x squared minus 9y squared equal negative 144. Right. So I'm going to subtract both, I'm going to divide both sides by 144. So I have 144 divided by 16, which is give you what? 144 divided by 16, which give you 9. So I have x squared over 9 minus 144 divided by 9 is you have 16. Is equal to negative 1. So it's not in the form yet, so I'm gonna multiply both sides by negative 1. Then I can switch position. Here you go. So this is your B and this is your A. So B will be 4, A is 3. Right. So from there we can get the vertex. So B1 will be 0, negative 4. B2 will be 0, 4, right? And you can get A1 and A2 if you want to. You can get C. So C is C squared equal to A squared plus B squared, right? So C squared will be 16 plus 9, right? Will be 25. So C will be 5. So you can get the coordinate of the focus will be F equals 0, F1 will be 0, negative 5. F2 will be 0, 5. Right. And you can find the eccentricity E will be C over B, right? C over B, so it will be 5 over 4. That is eccentricity. The directrix equation, y equal to plus minus b over a, x, so it will be plus minus this is asymptote. B over a will be 4 over 3 x. Okay, and directrix equation will be y equal to plus minus b square over c. Okay, b square over c, right? I remember it should be, yep. So it should give you plus minus, it will be 16 over 9. No, 16 over 5. I'm sorry, c is 5. C is 5. Okay, here you go. That's it. So if I give you the equation and ask you to find all the property, then you can go ahead and list everything out like this. All right. So the example number 1 is kind of simple. You know, everybody know. As long as you memorize, you know all the property here, then you can do it. All right. On the example number 2, I will ask you to write equation. Okay, let's see. Let's see. All right, how about this? Right. Right. Equation of hyperbola. Okay. Which has major axis. Okay. Is y-axis. Okay. Minor axis equal 6, and eccentricity equal 5 over 4. All right. So how we do that? How we do this? Solution. So they say that this hyperbola has major axis is on y-axis. So it means what? It means that we have vertical, right? So the information on the question, it tell you, and you can use that to determine if the vertical hyperbola or horizontal hyperbola. They also give you minor axis equals 6. It means that they give you a1, a2 equals 6. a1 equal to 6, it means that you can get a equal 3. Because you want to write equation, you need to find a and b. You need to find a and b. So you got a from that information already. Now you need to find b. So we know that e equal to 5 over 4 and e equal to b over c. Right? According to eccentricity, e equal to e equal to c over b. I'm sorry. See? C over b. E equal to c over b, not b over c. So c over b. So from here, what we get? C over b. Okay, we cannot get anything. However, we know the relationship. We know that c squared equal to a squared plus b squared. Alright. So from here, I can get c. You do cross multiply, so c could be 5b over 4, right? Then you're gonna plug in here, so we have 5b over 4 square a square could be 9 plus b square, right? So from here I can solve for b, so it could be 24. 25 over 16 b square equal 9 plus b square. So subtract both sides by b square, so have 16 and 55 will be 9 over 16 b square equal 9. All right, then I cancel the 9. It means I have 1 over 16 b square equal 1, so it means that b square equal to 16. All right, so I got b square, I got a, then you can write equation. So y square equal to 16 minus x square equal to 9 equal 1. There you go, easily. Okay. Again, I can give you different property, and you use those properties to write equation of hyperbola. So it's not you have to learn math by logic. Okay, don't learn it by look at this example and you mimic the example. Of course you can mimic the example, however make sure that you really understand it, so that when I change something in the question, then you should know how to do it. Okay, all right. So that is the way you write equation of hyperbola. So for the hyperbola which the center is not at the origin, you could do the same. Okay, I'm not gonna give you example anymore, because I just figured out everything is the same. For the hyperbola, for the vertical hyperbola, I'm gonna give you something like this, like last time. You know, I'll probably ask you to write equation of hyperbola with the center is not at the origin, but yeah, I mean I can find something else and work on that. Probably we have another example. Let me check. Okay, let me check. You know, let's see we have anything here or not. All right. All right. So hyperbola. Okay. I can have something like this. Example number 3. Right. Equation of hyperbola which center is 9, -7, and have focus is one of the focus is 9, 3, and one of the vertex is so one of the vertex is 9, -1. Okay, let's say we can do this or not. So we know, so this is the vertex. We don't know this is vertical or horizontal. So we need to figure out, we need to determine is this vertical or horizontal first. Okay, so the center is 9 and -7. So let's draw it. 9, -7. So we should draw it, because when you draw it, then you know. So 9, 1, so say 9. I think it's 8 over here, so 9 right here, and -7. So it's 8 right here, -7, 7 right here. So this is the center. So this is -7. This is 9. So this is the new center. Okay. and they have the focus is 93. So 93, so the focus is here. So they have F right here. Oh, here you go. So the center right here and the focus over here. So it means that this is the, I'm sorry, I need to move a little bit up. This is should be the F2, right? You got F1 should be all the way down here. Should be good. It's 93. So is that 9? 1, 2, 3, 4, 5, 6, 7, 9, and 3. So 3 up here. I'm sorry, it's the 3 up here. Here you go. And so the distance. So you can get the C value. So be 1, 2, 3, 4. 1, 2, 1, 2, 3. 3 is 10, right? So it will be 10. So we have 7 here. So we have 1 here. So we have 1, 2, 3, 4, 5, 6, 7. So 8, 9, 10. There you go. It's 10. Because over here is 7 already, and it's 3, so it could be 10. So I have 8 over here. It will be 8, 10, 10 right here. Okay. So from here to here. From here to here is 10. So this is F1 right here. Okay, F1 right there. And they say that one of the vertex is 9, -1. You see, the vertex is, you see that the vertex is on the same line with the axis, the major axis. 9, -1. So 9 here, -1 right here. So this is one of the vertex. So this is your B2. Okay. So you count like how many value from the center. So you have 1, 2, 3, 4, 5, 6. All right. So 1, 2, 3, 4, 5, 6. So right over here. So A, B1 right here. Okay, right. 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. So that's B1 right here. So B1 right here. Okay. So I mean that our hyperbola, something like this. There you go. And there you go. A hyperbola or something like that. So this is the vertex. Okay, this is F. So we know that this is a 6 unit, right? 1, 2, 3, 4, 5, 6. This 6 unit. Okay, that's the B value. We know the center. The center is so this is vertical one. So we know the equation so will be y minus minus. So will be y plus 7 over b square minus x minus 9 over a square equal 1. So our job is to find a and b. So this is your b unit right here. And we already know c is from here to here. See how many units for c? So c is from here. So c is 1, 2, 3. C from here to here. So how many you do? It's 10, right? Because this is 7 already plus 1, 2, 3. So it's C10. All right. So we know B is 6, C is 10. So I can get A, right? So we know C square equal to A square plus B square. So A square equal to C square. So it will be 10 square minus 6 square. So it will be 100 minus 36. Alright, so 100 minus 36. 36. So would use give you 64 is A square. Then you see that you can get the equation easily. So my equation will be y plus 7 square equal 36 minus x minus 9 square equal Oh no, I'm sorry. This b squared equals is 36. A squared 64. Yes, so it's good. I thought I got it right. Equal 1. There you go. Yeah. So you see the by sketching the hyperbola and counting the value, you can get ABC easily. So this is C equal. Okay. Don't do it by the formula. If you read the textbook, you know, they say that okay, in order to get C, you minus H, blah blah blah. So don't do like that, okay? Because if you do like that, then I just need to change the letter. You can really confuse. You don't know which one A, which one B, which one C. Okay? You just draw the now them and you start counting. Okay? So in order to get a good drawing, you know, make sure that your paper, if your paper has the grid, then it will be easy. If you don't have a grid, then make sure that you divide x and y axis into equal increment. So your coordinate system should be pretty perfect in order I'm sorry, in order to get a good graph. Okay, then if you get a good graph, then you can get ABC value easily. Then you can get the equation. Okay. All right. So I think I'm gonna stop right over here for section 8.2. In the next section, we'll be learning how to solve system of nonlinear equation. We will do kind of more difficult problem than the problem we did in college algebra, but as usual, the concept is not really hard, but you need to practice a lot. All right, and I'll see you next time in the next video. Bye bye.